Hello everyone, welcome back. In previous lecture, I explained about the liquid in glass thermometer. Let us recall about it. Liquid in glass thermometer. So this was the simple construction of the liquid in glass thermometer. Then the description about it, the working principle of it, and the range for various liquids. Then the salient features and characteristics. Now in today's lecture, I will explain about the bimetallic strip, and we will see one more device for temperature measurement, that is thermometer, or sorry, that is thermocouple. Now in bimetallic strip, you will find one particular strip, this over here, which is made of two different material are of T1 and T2 thickness. What happens when the materials comes in contact with the temperature? It will deflect, and that deflection will be used for the calculation purpose. Now, how it will be possible? There will be two different materials used. One will be having the low expansion material and another will be the high expansion material. यानी कि एक मटेरियल ऐसा होगा कि जो ज़्यादा एक्सपांड करेगा और दूसरा कम एक्सपांड करेगा। अभी जैसे ही यहाँ पे टेम्परेचर अप्लाई किया जाएगा तो क्या होगा कि ये जो मटेरियल है, सपोज ये स्टील है, तो ये कम एक्सपांड करेगा, और यहाँ पे सपोज दूसरा कोई मटेरियल है जो ज़्यादा एक्सपांड कर रहा है, तो वो ज़्यादा एक्सपांड करेगा। उसकी वजह से क्या होगा कि हमको कर्वेचर मिलेगा, और उस रेडियस ऑफ कर्वेचर से हम पता लगा सकते हैं कि टेम्परेचर कितना है। Now, for that, we have to consider the n as the ratio of modulus of elasticity of low to high expansion material, that is the E1 by E2, whereas the alpha 1 is the lower coefficient of expansion, then alpha 2 is the higher coefficient of expansion. Similarly, the temperatures T and T0. T is the operating temperature and T0 or O is the initial bonding temperature. If the T1 is equal to T2 and if the material are so chosen that the elasticity of both material is same, then the radius will be given by 2t upon 3t minus t0 into alpha 2 minus alpha 1. So this is the equation of R, and generally R is very large and movement of free tip is very small. जो हमारे रेडियस ऑफ कर्वेचर है वो बहुत ही ज़्यादा होगी, और जो फ्री टिप की मूवमेंट है वो बहुत ही कम। However, the tip deflection can be increased with choice of material that give a large value of factor alpha 1 minus alpha 2. अभी यहाँ पे जो टिप का डिफ्लेक्शन है वो हम बढ़ा सकते हैं by varying the value of alpha 1 and alpha 2. Normally, the low expansion material such as INVAR, an iron nickel alloy containing about 36% nickel, and high expansion metal such as brass, they are used. देखो यहाँ पे दो डिफरेंट मटेरियल दिए गए हैं। एक है इनवार जिसका एक्सपांशन क्या है, लो एक्सपांशन मटेरियल है, और वो किसका बना हुआ है, विच इज मेड ऑफ 36% निकल, और उसकी जगह पे दूसरा जो हाई एक्सपांशन मटेरियल है वो ब्रास है। नाउ द रिस्पेक्टिव कोफिशिएंट ऑफ एक्सपांशन ऑफ इनवार एंड ब्रास, यहाँ पे जो कोफिशिएंट ऑफ एक्सपांशन है उसकी वैल्यू यहाँ पे दी गई है। फिर ये फिगर आप देख सकते हो कि जो टिप का डिफ्लेक्शन है वो यहाँ पे y के फॉर्म में दिया गया है। y जो है वो टिप का डिफ्लेक्शन इंडिकेट करता है। When a bimetallic strip in form of cantilever is assumed to bend through circular arc, then R plus dr upon R is equal to expanded length of strip having higher expansion coefficient and expanded length of strip having lower expansion coefficient. जब भी जो बायमेटालिक स्ट्रिप है वो सर्कुलर के फॉर्म में हम अज्यूम करेंगे तो उसके लिए जो चेंज इन लेंथ टू ओरिजिनल लेंथ दैट विल बी स्ट्रेन, और जो यहाँ पे आर प्लस डी आर यानी कि जो इंक्रीज्ड एक्सपांडेड लेंथ है वो कितनी होगी आर प्लस डी आर, और जो एक्सपांडेड लेंथ फॉर लोअर expansion coefficient that will be proportional to r, and that value can be given by 1 into L into 1 plus alpha 2 minus t into t minus t0 upon L into 1 plus alpha 1 into t minus t0. The simplification, if we give the LL will be cancelled out and the R will be given by the, if we take simplify we will get the equation of R in this form: R is equal to dr into 1 plus alpha 1 t minus t0 upon alpha 2 minus alpha 1 t minus t0. So this is the equation for radius of curvature. With low expansion metal of invar and thickness of each metal strip T by 2, alpha 1 is approximately 0 and dr is equal to T by 2. So with this stipulations, the equation reduces to R is equal to T upon 2 alpha 2 minus into T minus T0. The movement of free end of cantilever in a perpendicular direction from initial horizontal line is worked out as angular displacement, that is equal to theta is equal to 1 upon r, whereas the vertical displacement y is equal to OB minus OA is equal to r in minus r cos theta. यहाँ पे आप देख सकते हो कि ये जो वर्टिकल डिस्टेंस है यहाँ पे O से B तक का डिस्टेंस, उसमें से ये जो ए बी है वो हम माइनस कर सकते हैं, तो हमको ये वर्टिकल डिफ्लेक्शन y मिल जाएगा. When one end of bimetallic strip is fixed, the position of free end is in direction of the temperature of strip. When the bimetallic element can be arranged in flat spiral, single helix and multiple helix configuration. One end of helix is anchored permanently to the casing and other end is secured to pointer that sweeps over a circular dial graduated in degree of temperature. In response to temperature change, the bimetallic expands and helical bimetal rotates at its free end, thus turning the stem and pointer to new position on dial. Likewise, the curvature of bimetallic strip varies with the temperature and causes a pointer to deflect. The continuous strip would wound into helical or spiral form has the advantage of compactness while providing a long length of strip required for adequate indicator movement. So this is description about the bimetallic strip as I explained earlier. Next instrument is pressure thermometer. The pressure thermometer consists of a sensitive bulb, an interconnecting capillary tube, and pressure measuring device such as Bourdon tube, bellows, or diaphragm. When the system is filled with liquid such as mercury or xylene, the commonly used under an initial pressure, compressibility of liquid is often small enough relative to pressure gauge dV delta V upon delta P that the movement is essentially one of volume change. The for a gas or vapor measurement system, the reversed is true, and the basic effect is one of the pressure change at constant volume. The capillary tube, as long as 60 meter, may be used for remote measurement, and the temperature variation along the capillary and at the end of pressure sensing device generally required compensation expect in vapor pressure type, and where the pressure depends on only temperature at the liquid's free surface located at the bulb. Another is the motion of compensating system is due to the interfering effect only and is subtracted from the total motion of the main system, resulting in an output dependent on only bulb temperature. The trimming capillary, which may be lengthened or shortened, allows the volume to be changed to attain accurate case compensation by experimental test. Now, bimetallic strips are also used to obtain the case and partial capillary compensation. So, here you can see there is the metallic strip over here in circular form. This will expand and the scale will deflect. यहाँ पे वेपर है और ये volatile fluid और non volatile fluid. ये वेपर प्रेशर थर्मोमीटर. The volatile liquid surface is always in the bulb, while the capillary and the case correction are not needed in such a device, since the vapor pressure of liquid depends only on temperature of its free surface. The commonly used volatile liquids include ethane. यहाँ पे जो वेपर प्रेशर है वो दिया गया है that changes from the 140 kPa to 4 MPa gauge, and for temperature change from -73 to 27 degrees centigrade. Another liquid which is ethyl chloride, उसके लिए भी प्रेशर और टेम्परेचर दिया गया है, और उसके अलावा क्लोरो बेंजीन, उसके लिए भी प्रेशर और टेम्परेचर रेंज दिया गया है. The accuracy of pressure thermometer under the best condition is of order of plus or minus 0.5% of the scale range. The adverse environmental conditions may increase this error considerably. So this is about the pressure thermometer. Another device is the thermocouple. Now, as I earlier told about the Seebeck effect, the if two wires of different material A and B are connected in circuit with one junction at T1 temperature and another is supposed at T2 temperature, then an infinite resistant voltmeter detects an इलेक्ट्रोमोटिव फोर्स दैट इज ईएमएफ. यहाँ पे वोल्टमीटर जो है वो ईएमएफ को मेजर करेगा. एंड इफ एन एमीटर इज कनेक्टेड, अ करंट इज मेजर्ड. अगर ए मीटर हम यहाँ पे कनेक्ट करेंगे तो वो यहाँ पे करंट के फ्लो को इंडिकेट करेगा. द मैग्नीट्यूड ऑफ वोल्टेज ई depends on the material and temperature. The current I is simply E divided by the total resistance of circuit including ammeter resistance. जो यहाँ पे V इज इक्वल टू आई आर इक्वेशन आपको मालूम होगा, तो V यहाँ पे क्या है, E EMF. सो E I इज इक्वल टू क्या होगा, E अपन टोटल रेजिस्टेंस ऑफ द सर्किट. सो यहाँ पे एमीटर भी फिक्स कर सकते हैं और वोल्ट मीटर भी फिक्स कर सकते हैं टू मेजर द difference in temperature. Now, the thermocouples formed by welding, soldering, or merely pressing the two materials together, giving the identical voltage. If the current is allowed to flow, the current may be different since the contact resistance differs for various joining methods. Now, the welding, either gas or electric, is most widely used. Another, both silver solder and soft solder are used in copper constant couples. The special capacitor discharge welding devices, particularly needed for very fine wire thermocouple, are also available. Then the ready-made thermocouple pairs are of course available in wide range of material and wire size. So these are the common thermocouples which are used, and this is about the thermocouple. And with this I'll end the chapter, and this is it for today's lecture. In next lecture we will start new chapter. Thank you very much for listening me carefully. Have a nice day.